Today we are going to be looking at determinants. Under determinants, we shall look at the determinant of order 2. We shall also look at the determinant of order 3. The importance of determinants here is that we can use it to solve simultaneous equations involving 2 variables and the ones also involving 3 variables. Determinants of order 2 by 2. Let's refresh. Giving A equal to A, B, C, D, that is a matrix A equal to this, the determinant of A, written modulus of A, is equal to the modulus of the elements A, B, C, D, and this is calculated as AD minus BC. The main diagonal, the product of the elements in the main diagonal minus the product of the elements in the other diagonal in a 2 by 2 determinant. Only square matrices have determinants. If the determinant of a square matrix is 0, the matrix is a singular matrix, which means that the matrix has no inverse transformation. Thus, if the determinant of the matrix A is equal to 0, the matrix A is singular. I also explained to you before now that a square matrix has the same number of rows and the same number of columns. Example number 1. If the determinant of this element is equal to the determinant of this element, find the value of S. Our solution: the main diagonal in the first one, 2 times 3s, subtract the product of the other diagonal, 5 times 3, and this will be equal to 4 times 2s minus 3 times 1. This simplifies to 6s minus 15 equal to 8s minus 3. Collecting like terms, 6s minus 8s minus 3 plus 15 minus 2s is equal to 12. And therefore S is equal to minus 6. Example number 2. If P is equal to the matrix S plus 3, S plus 2, S plus 1, S minus 1, evaluate S if the determinant of P is equal to minus 10. Solution: your P will be equal to and this becomes multiplying S plus 3, S minus 1 minus S plus 1, S plus 2. Open the brackets. This will give you S squared minus S plus 3S will give you plus 2S. 3 times minus 1 is minus 3. Minus is there again. Because of this minus, it will be proper to open another bracket. Even though we are opening the brackets here, this becomes S squared, and that is plus 2S plus 1S is plus 3S, and 1 times 2 is plus 2. And that becomes S squared plus 2S minus 3. You can now open this bracket to give you minus S squared minus 3S and minus 2. If you simplify this, S squared minus S squared, and then you have 2S minus 3S will give you minus S, and then minus 3 minus 2 will give you minus 5. and you are told that the value of this one is equal to minus 10. So, with that, our minus s is equal to minus 10 plus 5, giving you minus 5. Therefore, your s is equal to a positive value of 5, that is plus 5. Minus will cancel minus. Example number 3, a matrix P equal to A, B, C, D is such that P transpose is equal to minus P, where P transpose, P power T is the transpose of P. If B is equal to 1, then P is that. We have the options A, B, C, and D. In this case, we will try one of the options. Let our P be equal to 0, 1, minus 1, 0. Try and correction. Now, if this is our P, then our P transpose is equal to interchanging the main diagonal and signing the other diagonal. So if you sign this, you have this relationship. And that this value is equal to minus P. And minus P is 0, minus 1, 1, and 0. Therefore, from what we have seen in this case, the matrix that satisfies this equation is the matrix 0, 1, minus 1, and 0 is the correct answer. So option B is the correct answer. Example 4. Given that the matrix Q is equal to this, and the matrix Q plus P is equal to this, evaluate the determinant of Q plus 2P. Our solution, first and foremost, we have that Q plus P is equal to this, so we get our P. Our P therefore will be equal to 7 minus 2, 6, 8, minus Q, which is 6, 0, 4, and 5. So component by component, 7 minus 6 is 1, minus 2 minus 0 is minus 2, 6 minus 4 is 2, 8 minus 5 is 3. This is your matrix P. Therefore, our 2P will be equal to 1, 2 multiplying this, that is 2, minus 4, 4, and 6. This will be the matrix of 2P. Then we are looking for the determinant of that, but before then, our Q plus 2P will be equal to adding the two matrices together. Our Q is 6, 0, 4, and 5. And this should be added to the matrix 2P, which is 2, minus 4, 4, and 6. And when you add this, you will have our Q plus 2P, the determinant, will now be equal to this. We evaluate this one. 11 times 8 is 88, minus 8 times minus 4 is minus 32. And of course, this becomes plus. And the result of that will be 88 plus 32, and that is equal to 120. And that is the solution to the problem. Determine S plus Y if this matrix times this is equal to this. Let me use this to explain something to us. It is like saying the matrix A times S is equal to B. Usually, we are to look for the value of S, and that means we are dividing B by A. And the division by A means multiplying the inverse of A by B. Remember the laws of indices. So in the real sense, we are saying that our S is equal to the inverse of B. Now, but before we go on, I want us to use determinants to solve this problem. We're going to use determinants to solve this problem. And how are we going to do that? we have, using determinants, we can write now that this equation becomes 2 minus 3 minus 1 and 4. And the determinant of this one will be equal to 8 minus 3, and that is 5. So the first thing is getting the determinant. Let's call it this delta symbol. When we are getting that, we now write, because we are looking for S, we have S and Y. The first column is for S, the second one is for Y. Replace the first column to have the determinant of S. Replace this first column by the right hand side, which is minus 1 and 8. And here is minus 3 and 4. Find the value of this. This will give you minus 4 minus 24. And the result is equal to 20. Then do the same thing to Y. Replace the column of Y with the right hand side. So you are left, your 2 minus 1 is here, replacing it with minus 1 and 8. 8 times 2 is 16. 16 minus 1 will give you 15. Our answer therefore becomes, our S will be equal to the delta S all over delta. And delta S is 20 and delta is 5. And the answer here is 4. We also now have Y will be equal to delta Y over delta. And delta Y over delta will give you 15 all over 5. And the result is equal to 3. Therefore, your S is equal to 4 and your Y is equal to 3. Alternatively, we have multiplying out the matrix. You have 2S minus 3Y equal to minus 1. Call this equation 1. And you have minus S plus 4Y equal to 8. Call this equation 2. You cannot solve equation 1 and equation 2 simultaneously. A fact or a knowledge that you are conversant with at this level. So you solve this equation and this equation simultaneously. The first method I use is called the Cramer's rule. The method 1 above, method 1 is called the Cramer's rule. By inverse method, we have A times S equal to B, which I wrote earlier. Looking for S means that we find the product of the inverse of A times B. Our A is equal to this matrix here. And the inverse of A is equal to 1 over the determinant of A times the adjoint of A, which we sometimes call the C transpose, the cofactors transpose of A. You now calculate the determinant of A. And you write this, you multiply 2 by 4, 8. Minus 1 times minus 3 is plus 3. The minus sign is there because that is the formula. You have 5. So we have gotten the determinant of A. The adjoint of A is simply, for the 2 by 2 matrix, you switch the entries. The one in the mid diagonal, you switch them. And then of course you sign the other values. If you sign minus 3, it becomes plus 3. If you sign minus 1 becomes plus 1. That is negative signing. Negative signing. So we have the adjoint of A. So please, it is not difficult for you to find the adjoint of a 2 by 2 matrix. You just switch the main diagonals and then negative sign the other values in the other diagonal. Now, our A inverse now becomes 1 over 5 into the adjoint of A. That becomes, for us to now get the value, you multiply your inverse by B, and our B is minus 1A, also a matrix, a column matrix. If you now multiply each of these one out, you have the value for S and the value for Y. And this is done as follows. 1 over 5 times 4 is 4 over 5. And then this is 3 all over 5. And then this is 1 all over 5. 2 all over 5. And this will also multiply the column matrix there for B. And the result you will get will be equal to S and then Y, also in the column matrix form. So multiply this out. The first one is minus 4 over 5 plus 3 times 8 is 24 all over 5. This is equal to your S. And when you do this, minus 4 plus 24 is 20. So this is 20 all over 5. And the answer is 4. For the second row, minus 1 over 5 plus 2 times 8 is 16 all over 5 is equal to your Y. That means your Y will be equal to, simplifying this one, 15 all over 5. And the result is equal to 3. Therefore, your S is equal to 4 and your Y is equal to 3. You will now discover that these three methods of solution gives you the same result. So you are now at an advantage. You can use the Cramer's rule. You can use the simultaneous equation system to also find the value. You can also use the inverse method. Example 6. Given that the identity matrix of order 3 is a unit matrix of order 3, find the determinant of the identity matrix. First of all, an order 3 identity matrix is of this form. It's a 3 by 3 matrix, 3 rows and 3 columns. And you are told to find the determinant of this one. To find the determinant of this order 3 matrix, recall that I said earlier in course of this lecture that we sign the elements in the matrix or the determinant. When we sign these elements, we will use them. The first element is 1, which is plus 1. You destroy everything along this line and also destroy everything along this line. What you have left is 1, 0, 0, and 1. Of course, this is 0, this is 0. So when you multiply anything by 0, it will be 0. So you don't need to bother. You now simplify this one. 1 times 1 is 1 minus 0. And the answer is equal to 1. That is it. We'll now take a look at question number 7. This one says we should factorize completely. Factorize completely our s cubed, then y and y cubed. You have to factorize this completely. Solution: apply the rule of determinants, cross and multiply sy cubed minus ys cubed. Factorize this one. S and the y will be common. So one s is out, one y is out, remaining one y, 2 y, y squared. One y is out and one s is out, remaining s squared. If you look at this becomes your sy into y minus s and into y plus s. And this is the factorization completely of that given determinants. Here are the exercises. Number 1, which of the following matrices has an inverse? A, B, C, and D. Which of them here has an inverse? Number 2, if the determinant of this is equal to 15, find the value of S. You have the options. Number 3, if Q is equal to this matrix, then the determinant of Q is one of these options. That's correct. Number 4, if the determinant of this is equal to the determinant of this, find the value of S. A, B, C, and D options are there for you. Number 5, solve for S and Y. Given this matrix and this color matrix and this color matrix, find the value of S and Y. A, 3 and minus 8. B, minus 3 and 8. C, 3 and 8. D, minus 3 minus 8. Answers. The options, correct options are 1 is C, 2 is A, 3 is C, 4 is C, and 5 is A.